So, now we have to calculate magnetic field due to a solenoid. So, see here how do we make the solenoid? Actually, it is in the form of the helix and the wire is wound like this here, and when the current is passed through this wire, right. So, it is the current is like this is here, and this solenoid behaves as a magnet, as a bar magnet we can say. So, for deciding this, how does it behave as a bar magnet and which end is the south and which end is the north. So, simple way is here, just you imagine your position in front of the coil. If the direction of the current is anti-clockwise, that pole is north, that side is north, and if the direction of current is clockwise, then it is a south. So, in this case the magnetic field lines are going like this is here, and this solenoid has got uniform magnetic field inside it, and that we have to calculate. And see here the length of the solenoid is much longer than the radius of the solenoid. So, we have taken this is a long solenoid. Now, we have to calculate magnetic field using Ampere circuital law. So, now see here how do we calculate? Just we make this diagram in another way. Suppose this is a upper part of the solenoid here, and this is the lower part. It means from one side the wires are coming out and another side, this side the wires are coming outward to the plane and this side the wires are going into the plane. So, these points are here where the wire or the current is coming outward to the plane, and these are the point where the current is going into the plane. Magnetic field is uniform inside it. It is like this. Uniform magnetic field, direction of the magnetic field is to this side. And now, we assume here an Amperian loop like this, which is enclosing here this much part. This length is P, this is Q, this is R, and this is S. Outside the solenoid, magnetic field is negligible, that is 0 approximately. So, we can take this whole length of the PQ is L, and here this is the QR, this is RS, that is also equal to length L. And now, we can take N is number of turns per unit length. Here the number of turns is per unit length. Now, we will apply Ampere circuital law here. So, we can write B dot dl is equal to, here integration from P to Q, that is a B dot dl, plus Q to R, again B dot dl, plus R to S, B dot dl, plus S to P, and here B dot dl. And now, we will write the dot product of all these steps, and then we will be putting the values of the theta and the B. So, we can write here B dot dl, that is for the closed loop, is equal to P to Q B dl cos theta plus Q to R B dl cos theta plus R to S B dl cos theta plus S to P B dl cos theta. Now, see here theta is 0, B and dl both are in the same direction. So, theta is 0, theta is 90 in this case, dl is here. Outside R to S, we can take B is equal to 0, and in this case again theta is equal to 90. So, this part will become 0, this part will become 0, and this part will become also 0, only this part is left behind. So, we can write here B dot dl is equal to here B into, and we integrate dl here. So, with the length L, so we will be getting B into L. Now, we can use Ampere circuital law also. So, when we are using Ampere circuital law, we can write according to the Ampere circuital law, total line integral of the magnetic field over the closed path is equal to mu naught times the current enclosed by the loop. So, see here this is by the one turn current is coming. So, the total number of turns in this loop are, that is N into L, where N is the number of turns per unit length and L is the this length. So, now we can equate these two equations. So, we will be getting here BL is equal to mu naught I into NL, L and L will get cancelled. So, we will be getting B is equal to mu naught Ni. So, this is the magnetic field due to this long solenoid inside it that remains uniform. That basically depends on the number of turns per unit length, current passing through it, and also if you are putting something inside it, inside the solenoid, like you are putting the soft iron or something else or the magnetic material, then the magnetic field will become B is equal to mu r mu naught Ni. Then we will be introducing relative permeability of the material placed inside the solenoid. That will increase the strength of the magnetic field and that will be considered as an electromagnet.